Have you ever driven past a field of those giant wind turbines and just wondered, how on earth do they build those things? It is definitely not as simple as just putting up a really, really big fan. Today, we're going to break down the absolutely massive engineering feat of building a wind farm, all the way from a single blueprint to a field of giants powering our world. So what you're looking at here is, well, it's a monumental feat of engineering. I mean, building a single one of these is complex enough, but an entire farm, that's a whole other level. We're going to follow the entire journey, right from that first sketch to the moment it actually plugs into our grid. Okay, so our story really begins with that first spark of an idea. We're going to follow the path from that initial concept all the way to the final flip of a switch and see exactly how a simple blueprint becomes a towering reality. And let's be clear, this isn't just about construction. It's a really sophisticated process that combines some seriously advanced engineering with massive, heavy-duty construction, all to harness the power of the wind itself. Right, so you want to build a wind farm. Your first, and honestly your most critical decision, it isn't even about the turbines, it's about the land. Because finding the perfect spot, that's a science in and of itself. Yeah, it's not as simple as just finding a breezy hill somewhere. It requires sifting through just layers and layers of data, running complex analyses, and using some pretty advanced meteorological forecasting to pinpoint the most valuable and viable piece of real estate. The search starts big. Engineers are scanning for what they call wind corridors. Think of regions like the American Great Plains, where the wind is not only powerful and consistent, but crucially, where there's already an electrical grid nearby to connect to. Okay, so once they've got the region, they zoom way in for something called microsighting, which is basically placing each individual turbine. Using tech like LiDAR, it's kind of like radar, but it uses light, they create this incredibly detailed 3D map of the wind. This lets engineers position the turbines perfectly, making sure the wake from one doesn't slow down the one behind it. It's like playing a high-stakes game of chess against the wind. All right, with the perfect spot all mapped out, the digital blueprints get put away. Now the heavy lifting begins, as we go from computer models to actual concrete and steel. And it all starts deep underground. After analyzing every single inch of the soil, crews pour these enormous foundations. And these aren't just slabs of concrete. They are incredibly complex structures, reinforced with a web of steel engineered to anchor a skyscraper-sized tower against hurricane-force winds for decades to come. With that foundation secure, the tower starts its climb. And this part is like a logistical ballet. It requires specialized crews and some of the world's largest mobile cranes to hoist each massive section into place with just pinpoint precision. And then comes that moment where it all comes together. The nacelle, that's the box at the top with the generator and gearbox, is lifted into place. And that's followed by the rotor and its absolutely enormous blades. This is that final, iconic step that transforms a simple steel tower into a true power-generating machine. So, the turbines are built, they're standing tall against the sky. But you know what? That's only half the battle. Now, all that raw power needs a way to actually get to our homes. It's time to join the grid. This whole process is called grid interconnection, and trust me, it is extremely complex. Engineers run all these simulations to make sure the new wind farm can handle things like power surges and won't disrupt the grid's delicate balance. Essentially, they're making sure this new power plant can be a good neighbor to the rest of the electrical system. At the end of the day, all of this complex engineering, it really boils down to one simple goal: getting the clean power generated out in the field to travel seamlessly and reliably right into our homes and businesses. Now, you might think a wind farm is just a collection of, dumb spinning machines. But a modern wind farm is actually a highly intelligent, data-driven power plant. So it's time to meet the brains behind the brawn. So how well do these smart farms actually perform? Well, the numbers are pretty staggering. First off, they have an availability of over 97%. That means they are ready and waiting to generate power almost all the time. But availability is only part of the story. Because what really matters is how efficiently they use that time. With a 42% capacity factor, which, by the way, is incredibly high for wind power, they are just masters at converting wind into electricity. And this is a direct payoff from all that meticulous site selection we talked about earlier.
And the scale we're talking about here is just immense. A single portfolio of these projects can generate 1.2 gigawatts of power. I mean, that is enough clean energy to power a major city. All of this adds up to a massive economic engine. We're talking about over $2 billion in project value. That's a huge investment in our clean energy future. So, how is all this managed?
Well, this is the farm's central nervous system. From a high-tech control room, operators use what's called a SCADA system, that stands for Supervisory Control and Data Acquisition, to monitor absolutely everything in real time. They're tracking turbine performance, weather, grid conditions, making constant micro-adjustments to maximize every last drop of output. But what's even more impressive is predictive maintenance. Think of it like a fitness tracker for a giant machine. Machine learning algorithms analyze everything from tiny vibrations to the quality of the oil, predicting a component failure before it even happens. This proactive approach can slash unplanned downtime by up to 40%. It's a total game changer. And finally, these projects aren't just built for today. They are designed from the ground up to be the flexible, evolving energy hubs of the future. And this shows us the next evolution. Modern wind farms are built to be hybrid-ready. This means the same land and the same grid connection can be used to add massive battery storage systems or even a solar farm right next door. This maximizes the efficiency of the whole site and creates a much more reliable 24/7 power source. So, from a simple gust of wind on an open plain to an intelligent, connected power plant, we've really seen the incredible journey of a modern wind farm. It's a story of engineering on a massive scale, all powered by data, which, leads to one final thought. As these energy systems get smarter and more powerful, what do you think is the next frontier for clean energy?